Okay. Okay. Good evening, Mr. President, Mr. Mohammed Usari. Can you, I think it's time we could start.
Good evening, sir.
Good evening, everyone.
Yes, hello, good evening. Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, ladies and gentlemen. I'm Ghassan Al-Dosari, the AACE AGS President, on behalf of the AGS Board, and I would like to welcome you to our 5th technical webinar. I'm also glad to inform you that the next CCP certification course will start on the 21st of January 2022. Seats are available, and I request all professionals and top management to sponsor their professional employees to join our forthcoming certification courses and gain the valuable knowledge offered by these certifications. Today's speaker is Engineer Areeb Al-Amir, and he will deliver a technical presentation on offshore cost estimating, which is very unique, very specialized, and very specialized in the offshore industry. He completed his master's in industrial engineering and MBA from the University of New Haven, and he's also a certified cost estimator and value engineer. He's working with Worley AlKhobar as a cost estimator area lead, covering Saudi Arabia and Bahrain. He has more than 10 years of experience on major estimating commercial, cost, and schedule. Once again, thank you for joining us, and I hope that this webinar will be beneficial to you and your professional career. Back to you. Thank you.
Good evening, sir, from India.
Good evening.
Assalamu alaikum. So, Mr. Hassan, can I start? Huh?
Yes, please.
Yes. First of all, I appreciate all the attendance for this session. Sorry. Sorry, I don't know why the slides. Yeah, okay. This session will be divided into 2 parts. First, we will discuss the estimating background, and that's include introduction and the purpose of estimation, some definition of cost estimate. Then we will demonstrate some of the importance and benefits of cost estimating. Then we will talk about the type of cost estimate in relevant industry, followed by the basic procedures and the process to develop a cost estimate, and basic component and basic tools of cost estimating. At the end of part 1, we will touch on base with the cost estimating methodology, which consists of types of and methods of cost estimate. At the end, before we open the floor for questions, we will demonstrate a case study for offshore environment for a subsea pipeline. Before starting any engineering project requiring expenditures, it's needed to ask how much it will cost. So estimate is the preparation model that is designed to minimize the risk and to provide accurate contracting cost and the pricing proposal. It can develop for both contracting that used for commercial or government, such as construction, manufacturing, or subcontracting. The application of cost estimate can be used for feasibility study or selection among alternate design sites or investments, or we can use it for the presentation of bids or preparation of funds. Cost estimating can be defined as the art of approximating the probable worth or cost of an activity based on information available at the time. And the time here very crucial in developing the cost estimate, especially for construction industries, because through the project phases, the development of the time will develop more details that can provide better understanding and definition of the project. And this will improve the cost of that project, or can be defined as a methodology used for predicting or forecasting the likely future cost of a product or service based on the information available at the time, which both scientific and artistic discipline used through the product life cycle and used for commercial and company requirements. Also defined as a well-developed art. And you can see the art here, it's presented in each definition because it's required the skills. It's required the skills that needed to have in hand in order to understand the nature of the project, and we can drive the cost based on the available data in hand. Final estimating can be defined as the key to successfully convise and manage and completed the project. A cost estimate defined as a completion of all the elements of the project or effort, including within an agreed upon a project scope. The importance of the cost estimate application, we can say it's reduced the project risk, either not winning the contract or losing money, or reducing or eliminating the surprises for management, for better understanding for the project and make a better decision. Also, update the estimate with the continual improvement of accuracy to provide a follow-up for all those activities involved controlling the final capital cost, such as tracking the bulk account, progressing quotation, equipment delivery dates, and etc. And the benefit of the cost estimate can reduce the cost for business success, starting from the cost management process, and provides an integral link between technical and finance function. Also helps companies to realize their profit and increase market pressure, increase customer requirements, company merge, advances in technology, and relax the trade barriers. Also can gives a vital decision-making tool in design, in high-level design. Finally, it will ease the management to realize 80% of the product cost committed during early stage of the development. The cost that can be estimated divided in 3 types: the capital cost, operation cost, and disposal cost. Capital cost, which is composed of 2 parts: the fixed capital investment to provide the physical facility, or the working capital investment, comprises the value of funds in addition to fixed capital and the startup cost. Operation cost differ from capital cost mainly in that operation cost must be paid frequently, in contrast with the capital cost, which involve one-time payment. The disposal cost, which is required disposing the project. And I mean disposing the project, it means disposing the project, content at the end of its useful life. Estimating process is accomplished by applying the following The first step is the takeover step. This is concerned with the measurement of the quantity of work and the cost item driven from the scope documents. And the costing step dedicated to assignment of cost values to the element of work and related item in the project from the takeover of the material and the information presented in the scope documents. The final step is the pricing, where you assign for each line item a price based on market study, quotation, or in-house calculation. The basic component of cost estimate can be the man hours and the material and subcontracting or travel cost or other direct cost, labor rates, indirect cost, and profit and administrative cost. The man hours, it's crucial in any cost estimate, and it represents the human effect and time performed by individual with various degree of skills, training, and experience. Man hours usually estimated for each broad labor category of skills. Material represent the material cost, and this is given by the market. Each estimator, he send RFQs requested for quotation for different vendors in order to have and secure a material price. Travel cost, it's terminology for any transportation, either for equipment or personnel. Other direct costs, all the above the three, the man hours, material, and travel costs, considered to be direct. And other direct costs, such as the non-significant direct costs, such as the training. The labor rates, it's the rates that we applied for each man hours in order to convert it to cost. Indirect cost, the cost that usually consist of overhead, labor burden, or material burden that cannot be considered as a direct cost in the project. Administrative basically means the G&A, which is the administrative expense. So all of these, it's the basic component of cost estimate that need to be costed and captured through the project. The basic tools of cost estimating consist of 5 tools, which are the estimators. Basically, to develop an estimate, you need a team of estimators or an estimator. A mathematical approach, you need to convert your scope to cost model in order to convert it to prices. Also, you need a knowledge and data or experience concerning the project, the process, the product or service, plus the capability of computation and application of the estimate. You need to have a mathematical ability to convert everything and deal with adding and subtracting and etc. Also, you need the capability to be able to present it in a way that everyone can understand your cost estimate. The cost estimating methodology consists of work breakdown structure, the WBS. And the WBS basically means you break down your scope to the smallest element where you can assign or allocate a cost for that activity. Also, you need ground rules and assumption. Define all the factors that can influence the cost of the project. Also, a selection criteria about which type you're gonna use, which accuracy you're gonna apply, which input you're gonna use for that project. Then you need to construct a cost model, gather and normalize the data. That means you're gonna rely on inputs from others, such as engineering department, different engineering discipline, that quantify the scope for you, provide it as a quantity. Then you will be at the final step able to document it in a way that can be presented anytime, especially for the senior management. The American Association of Cost Engineers has 5 classification or 5 types of cost estimate. The first one, order of magnitude, or we call it OME. And this has accuracy from minus 50% to plus 50%. The second type, it's the study or factored estimate. The accuracy range from minus 25 to plus 30%. The budget authorization estimate, primarily, the accuracy again from minus 15 to plus 20. Definitive or project control estimate range from minus 10% to plus 15%. Then, or number 5, it's the detailed or the final estimate, and in businesses refer it as ER estimate. This is from minus 5% to plus 10%. Later, I will demonstrate for you what we mean by the accuracy. Method of cost estimating. We have 4 methods in order to derive a cost for anything, for a project or a product or anything. The first one called the expert opinion. And this one applicable once there is no data available for the project. Example, in the absence of the basis or the design, we can use the expert opinion. It's his sense how much it's gonna be cost. This is a quick, simple, inexpensive. The other method called the analogy. It's this type of estimate based on the actual cost of similar program. We refer it as a benchmarking. You just take a similar project and apply the same basis to your current project. The third one, known as parametric estimate. The parametric cost estimate, BCE, techniques developed from the Department of Defense, the US Department of Defense. And this method, cost estimating relationship, the CARS, driven from historical cost data, and then used to estimate the cost of similar future project. These CARS relate the cost of the system to its technical parameters, such as size, power, or weight. So you can convert it all your inputs in uniform units by size or by power or by weight. Then you apply one price for that unit. The fourth one, it's the detailed engineering, industrial engineering method. basically rely on in this one, you rely on all project deliverables, such as scope documents, engineering drawings, engineering MTOs, construction schedule, construction contract, and etc. And you can drive your cost, bases, rates, etc. from those deliverables. This is more detailed, more accurate, but it's most expensive. Okay. Now we will start the technical by discussing a case study for offshore pipeline. Let's say we have our project or our scope is to install a subsea pipeline with a 24-inch in diameter and 23.8 mm in wall thickness, with a total length of 19.6 kilometer. It's going to be purely installed on the sea, offshore. And from those terms mean from offshore facility to another offshore facility. So all the construction activity is going to be held on the sea. First of all, if you see those pictures, excuse me, Peter, if you can mute. Yeah. Okay, those pictures shows the pipe laying vessel. It's the main vessel that used as construction equipment. So all the activities for that project, it's gonna be held in this part. All the material, it's gonna be provided from onshore to this part, or the construction activity that's involved the welding of the pipes, it's going to be done through the crew who's accommodated in this part, plus the accommodation of all the manpower involved in that project. They will be in the pipe laying part. So the material brought using a material barge from onshore, loaded in this vessel. The barge crew will handle the material to the welding floor. They will weld the joint, then they will start laying the pipe using the white string on the sea bed. So we need to calculate the cost of all this activity, including the material and the construction. And the construction here involves two things: the installation of the pipe and the fabrication. So let's go over them one by one. And this is the material. The estimator receive MTOs. Usually the project consists of more than one pipeline. I mean, it's going to be several pipelines, because the cost of bringing this vessel, it's too expensive. It costs around $500,000 per day, $500,000. So we will try to maximize the utilization of that vessel. In this case, we develop, once we develop the estimate, you as an estimator, you came up with the construction philosophy. And based on your estimate, everyone gonna rely not only the cost that you provide, also the construction activity. They're gonna rely, for example, in scheduling, they will base the project schedule based on your resources. And I mean by the resources, for example, if we talk about pipe laying barge. It's about the estimator who will decide to use one vessel or two vessels. So minimizing the cost or minimizing the time. So the material, as listed here, it's for the bare pipe plus, you know, the pipe consists of the steel pipe plus the coating, because this subsea pipe gonna use for oil, and it need to be coated internally and externally in order to sustain the pipe, plus to prevent any leaking of the oil. Also, we have spools. Spools here mean at the end of in the both ends of pipe, we need to install spools in order to connect this pipe with the offshore facility, which we have two here. So once we receive the MTOs, you send it for a market and get a price for all this listed material. And you can see it here. Against each quantity, we have a price. And this is come from the market, from the different vendors. And usually we approach more than one vendor, and we select the lowest price. After the material, after we have all the prices, we add allowance to each line item. And this is known as Incoterm. In each quotation that you receive from the vendor, there is Incoterms involve the delivery, the assurance, the customer clearance, the taxes, etc. So for example, if the vendor specified the price for, let's say, for the bare pipe, the 24-inch, it's gonna be 411 bare meter. And in the quote, he said, this is gonna be in terms of X work out of kingdom. So in that price, you need to add 15.55 to capture all the involved in this term. And you would do this for each line item, for each material. And after you add the Incoterms, you will add allowances, involve the profit, the design, because those quantity provided to the estimator as a net quantity. So you have to add a 1% for waste, for MTO and design, plus 3% for escalation, and you will add a percentage for contingency and prorate. Prorate, you are developing the estimate now, let's say in 2022, but the construction, it will be in 2024, 2 years later. So you have to pro-factor your prices to be valid during that time. Okay. After the material, you will develop the fabrication and installation cost. The fabrication, it's involved the spools. The spools, it's as I mentioned, it's at the end of the pipe in order to use it as a connection between the subsea pipeline and the facility. And you can see here in our case study, we have 5 spools at the start and 3 spools at the end. You converted the meter to tonnage, and you can apply the factor here for fabrication. For example, for spools, you have the total 161 tons times $5,000 per ton, and you have the cost of spools. For material load out and land transport, because as I said, the material is going to be delivered from onshore using a material barge to the vessel on the sea. But before that, you're gonna need a land transportation from the material warehouse to the seaport, where the material barge will take those pipes to the vessel. So based on the total tonnage of the pipe, you calculated that you need 700 trips and $400 per trip. And you get the cost for land transportation. And for the load out, you have the total tonnages. The total tonnages, it will be 14,000 for both the pipe spools and spools. And you can apply a rate of $15 per ton in order to calculate the material load out. Then you have load out and tie-in for the barge. Once the material barge arrives to the vessel, and the transportation of the material barge itself to the vessel. This one is calculated to be 79 times the vessel rate, and you get the cost. So the total fabrication cost, it will be 3.4 million. For an installation. Installation, as I said here, for the pipe laying barge, it will cost $500,000 a day. And to install the 20 kilometer of this pipe, the 24-inch, you need 30 days. So basically you multiply the 30 days by the vessel rate and you will get the installation. And before you do an installation, you're gonna use some vessel for survey the seabed, like the pre-construction survey, the hydrographic, and the post-construction survey. And those days, based on previous project or in-house data, that you're gonna need this vessel for 5 days, and the hydrographic 4 days, pre-construction survey 3 days, and you have the rate of those vessels. You just multiply the rate, the daily rate, by how many days you're gonna use this vessel, and you get the cost. For spools in both ends of the pipeline, you're gonna use a tie-in spread because you need a diver to go to dive and connect the spools with the offshore facility. And here you have again the same methodology, 350,000 per day, and the installation date will be 49 days, and you get the total cost. And for the hydro testing and gauging and scrubbing the pipeline, from the pipeline engineers, they will provide you as input that they need it for 20,060 meters, and you have the rate per meter. You just multiply it and you get the total cost. So you gather all of them and you will get 36.9 for installation, and you can see it's too expensive. And this is the nature of offshore construction. It's unique environment.
So can you scroll the page up, sir? We cannot see the bottom line. After the time spread, we cannot see the bottom portion. Can you
okay.
Scroll the... Yes.
I'm sorry. You can see it now, or
no? We can see the time spread. Then the next line,
okay, the next line, because I cannot move the slide up actually, but the last line, it's involved the hydro testing. Basically, we are saying we gonna apply the hydro testing for 20,000 meter. So 20,000 meter multiplied by the rate, which is $150 per meter. And this came with 3 million. So the total installation cost, it will be 36 million. So 36 million for installation and 3.4 million for fabrication. And this is the main component of the cost estimate, the fabrication and installation. There is other cost also. Yeah, here I just put it for your own benefit. We don't rarely we face this here in Gulf, which we call it the dredging. Sometimes the barge not able to install the pipe because of the shallow water, which is 5 meters and below in depth. In this case, in those segments, we bring a dredging vessel. For example, the cutter section dredging vessel. And the mechanism of developing the cost of the dredging is different than the pipe laying. Here we calculate the total volume for dredging area. Then we have a rate here, which is 34 and 200 cubic meter per day. This is like the productivity for this dredging vessel. Okay. Then after the fabrication and installation, we calculated, as I said, the man hours. And as I said, we use in this project the pipe laying vessel and the tie-in. And we converted the duration into hours. Then we are assuming here for both the pipe laying and the tie-in spread, it's gonna be work for 24 hours. That's mean each vessel gonna need 2 superintendent in 2 shifts, 12 shifts each. And the other vessel like the hydro test or dredging, etc., it's gonna only work for 1 shift, 12 hours a day. So we converted all the duration into manpower into hours. Then we have it for the total superintendent hours. We have it here for the pipe laying spread, also for the tie-in spread, for the survey spread as well, and for the hydro test. The total man hours came to 2,800. And we assume 50% of total offshore man hours, it's gonna be onshore in-house support man hours. So 50% of the 2,800 offshore man hours, it's gonna be for onshore support, which is 1,400. After calculating all the required man hours, we apply the rates for each hour in order to drive the cost of the support for both offshore and onshore. And you can see here for administrative support, we have the total hours multiplied by the rate and we get the cost. For project engineers also, and for construction support and in-house support, this is the 2,800 for offshore, and this is the 1,400 for onshore, 50% of the offshore. And this is the meal allowances for the superintendent and the crew in each barge. We have the total number of days and the daily rate, and we can get the cost. Okay, so at the end, we develop a complete estimate, involve material, construction, include fabrication, installation, and the construction support cost. All those duration converted to man hours, multiplied by the hour rate in order to be converted in cost. Then the total cost of this pipeline, a 20 kilometer, 24-inch subsea pipeline, it will be around $60 million. One thing here before I close, the mobilization and demobilization here, what we mean by move and demove, it's the cost of bringing the vessel to the project site and then demobilized after the installation. Because usually the contract, the construction companies in offshore, they are few. And most of them, they are working with Saudi Aramco. And most of them, they have their fabrication yard in United Arab Emirates. So we take the cost of bringing the vessel from there to here, because once you have the contract, they will start, the contractor, he will start charging you once he move the vessel, and also he will charge you once he done of the installation until it's returned back to its original location. And this is what we mean by mobilization and demobilization cost. And usually mobilization and demobilization in offshore environment, it has a significant cost. Yeah. Okay. Yeah, that's it. If you have any question, please.
Okay, thank you very much, Mr. Areeb, for your very informative information. So if you have any questions, can you unmute yourselves or type in your questions? And Mr. Areeb is ready to answer it. I think we did not have any questions. I received one from the chat box. So they are asking for the copy of the presentation slides. And I think, is it okay, Mr. Areeb?
Yeah, it's
Yeah.
totally fine. Yeah.
Okay, thank you very much. Okay, any other questions?
Hi, I'm Mohammed Harris. I have one question. How do you account for the downtime, like the weather and storms, in the estimate?
Yeah. Okay. Let me go back here. We usually, once we have the total installation times in days, Muhammad, we apply from 15 to 25%. So, for example, if you can see here for the main vessel, the pipe-laying vessel, I have a 25 days for purely installation time. I added the 3.75, which is 15% of the actual duration time as a standby and weather downtime.
Okay. Yes. Go ahead, Mr. Ahmed Al-Shiri, for your questions.
Yes, good evening, everybody. Thank you, Mr. Areeb, for your valuable presentation. But I have a question regarding, just the, estimate accuracy levels. Is it aligned with, 97 recommended practice 18, which is, I think, or recommended 97 recommended practice 18, AACE? Because what I saw, there is not a correct accuracy level of the estimate. And this is my point.
Okay, yeah. For the accuracy, actually, I rely on the accuracy here from the AAC handbook, which I have it 20 years ago. Or 20 years ago. But the accuracy usually the type of estimate that we prepare, especially for Saudi Aramco, 3 types. The study estimate, which is plus minus 50, and we have what they call it a DBSP estimate, which has accuracy of a plus minus 30%, and the ER estimate. The ER estimate for Aramco, it's plus minus 5%. But this one provided here, this slide, I rely on maybe outdated handbook. I have it from AACE, but I'm glad to update those accuracy and share it with you.
It means to say you
Excuse
are
me,
referring.
can I come here, please, to add on what just said?
Go ahead, go ahead.
Yes, yes.
Assalamu alaikum. This is Khalid Maddallah. You know, about, you know, what our colleague, the question he asked, those things are relative. You know, I know what he is referring to, minus 30 plus 50. But if you really go into it, they start with minus 50 plus 100. Then it, you know, as you develop the scope, 5% minus 30 plus 50. But these things are relative. I mean, there is no right or wrong here. You know, some people, they might use minus 20 plus 40, minus 30 plus 50. So even when you receive a question in the exam for PMP or AACE, they will not give you like a clause to, you know, if they give you minus 20 plus 40, that's still order of magnitude. So there is no right and wrong here. This is basically relative. You cannot say what you are using. You know, if this is the way you are working, it's the way you are working. Just a general comment. Thank you.
Okay, thank you, Mr.
Okay,
Khalid. Yes. Go ahead.
Okay, thank you, Mr. Khalid. And there is another question which is related to the cost modeling, which is predetermined and early stage, especially for preparation of the estimate. Are you validating this estimate by case studies, which is, it seems to me, all variable or dependent variables missing the weather condition, especially when it comes to the offshore. You go to the offshore, there is rough weathers and a standby time. Are you included this in your case-based study to validate your estimate? This is the methodology, I mean.
Yeah, we take in account of the weather and the standby time. As I mentioned here, we apply 15%, and this is the best thing you can develop, because you know the standby and the weather, it's uncertain. You cannot forecast, you cannot predict, but you have to take a portion of the duration in order to be in safe side. You can argument 15, it's enough, it's not enough, it's not, but this is usually what we apply for any project, from 15 to 20% of the total duration as a standby or weather downtime.
Okay, thank you. There is one more question. Mr. Bahrain, can you raise your question, please?
Yeah, before we move to another question, also with regard to the validation, yeah, we to validate our estimate, not only for from the previous project, not only for the standby time. We do it actually even for the productivity of the vessel, because in order to once we calculate the production time, it's based on the productivity of the vessel, how many joints of the pipe they installed per day. So if we based our calculation and let's say 60 joints per day. That's mean 60 times 40 feet, because each joint has a 40 feet in length. And once we apply it for this project, we validated this number with the previous project. We gather all the 24 inches pipeline project that done before, and we take the average number of installation time in order to challenge our assumption, when also to validate our assumption to be realistic as much as possible.
Okay, thank you, thank you. Go ahead, Bala.
Hi, good evening. Thank you, Mr. Areeb. I have two questions. First one is that one. You have mentioned your estimation, material estimation. There is a percentage mentioned each activity wise. Can you show one time that how you arrived at percentages? You
mean in this one?
Yeah, this one. You have added percentage of material cost, 1%. This, how you fix these percentages, on what basis this one?
It's Incoterm, a standard Incoterms known worldwide. But this one validated by a finance department, our finance department. For example, in this presentation, I used, if you can see here, the onboard custom clearance, 5%. But nowadays it's 10% because they change it. So they inform us, they update this table, and it's likely whenever they have a update, they notify us, then we update our table.
So actually, suppose for example, loading charges, import and export is 0.5% loading on truck charges, 1% of total cost. Is this fixed? Is there any project is the fixed or variable? It will be.
No, it will be variable. It will be variable, but.
So on what basis next, suppose another project, on what basis we can assess that one, how much percentage?
Yeah, you can assess it with the vendor. For example, if the vendor provide you the quotation, the budgetary quote, and he mentioned that this is gonna be rely under Incoterms, let's say X work in Kingdom. You share the percentage with him. Plus, once you submit your estimate to let's say to your customer, usually the client, they will not take it as it is. They will do a validation. Sometimes with something it's confidential for you, but not confidential with them, like the contract, like they compare it instead of they compare the budgetary quote that you are using it as a basis of your estimate with a real purchasing order with the same material.
Okay, and what about DAT, DAP, DCPT, CAP? What does this mean?
Which one?
This last columns, so DAP, CPT, CAP.
Yeah, this I can share it with you now. Just give me a second.
Okay, so before Areeb, please
Yes.
looking for the answer. So we'll take only one more question, and then we are going to.
Yeah, for the time I will share it after
yes,
what's his name? Yeah, I will share it after after.
And one more last question. Do you have preliminary cost, example engineer cost, and how maintenance is required for any this type of projects? DLP, defect liability period, like anything is there required?
No, this is as a capital project. We
So
not consider no operation, the operation and maintenance. It's not involved. It's another. It's not part of the capital. It's not part of the capital project. But for the engineering, yeah, engineering basically in order to.
No, I am not talking about
okay.
operation. like if suppose construction of the building, if construction of DLP, defect liability period 1 year, or we maintenance, we have to give the client. For this type of projects also we have to assure like this. Anything 1 year free maintenance should to do like that cost where we have to consider. Is it applicable for this type of project offshore estimation?
You mean as operational and maintenance cost?
Not operational
Mr.
maintenance
Areeb,
cost.
I rephrase what he's asking? Maybe he's asking for a warranty for the project after completion, and then maybe they give 1 year warranty to maintain that before it's fully turned over to the owner.
Yeah, you know, just costs
Yes,
associated with the clause and exception items, Mr. Areeb.
Yeah, yes. Okay. So I hope so. We have short of time. So for those questions in the chat box, so maybe we are going to forward this to Mr. Areeb, so that he will answer it and share it with your email later on, or tomorrow or on the next days. So before we end, I would like to share a certificate of appreciation to our guest speaker tonight. So in behalf of AACE International Arabian Gulf Section, present this certificate of appreciation to Mr. Areeb Alamir for valuable guest speaker for virtual technical webinar presentation, Offshore Cost Estimating, held Wednesday, January 19, 2022 at given this at the Kingdom of Saudi Arabia via Zoom application. So thank you very much, Mr. Areeb, and all the participants, thank you so much. And maybe the slides will be shared by our administrator tomorrow or in the future days. Thank you. And don't forget to click the link for your certificate of attendance, share on the chat box so you read it backward so that you can click it. Thank you very much. Good evening, everyone. Closing for the closing, Susan is available. Alim, did you assign for the closing remarks or no need?
Hello.
Yes, Susan, go ahead, please.
Yes, thank you, Joe. Sorry, I was on mute. I would like to thank our speaker, first of all, for this informative presentation. Also, I would like to thank AACE for arranging this technical webinar, and thanks for all the attendees for joining us today. And that's it. Good night, everyone.